Assalamu alaikum. I'm creating this video for my very special students of grade 7, and I believe this video is going to help you all. So I've taken all the three relationships, which is subset, which is disjoint, and which was overlapping, right? So you will see in every case how the diagram is shaded and how the diagrams are different from the other case, which is for example the subset. How is it different from the overlapping set? How is overlapping set different from the disjoint set? So let's first start with the case 1, in which case we have given with the universal set, which is 1 2 3 4 5. A set as 1 2 3 and B set as 3. Now see, B has 3, which is which the element is present in A also. In this condition, where all the elements of one set are present in the other set, we call it subset. Remember, you always have to compare the two sets, which is A and B, and if there are more sets, you have to compare them together. So in this case, we have two sets A and B. So before drawing the diagram, we will compare the relationships, that what is the relationship in these two sets. See, B is a subset of A. By subset, I mean all the elements of B are present in it. See, 3 is also present in here also. So that means the diagram that we will make is B will be inside A, because A is the biggest set and B is the smaller set, so it will be like this. Now write the elements of B and the B, which is 3. Okay, now write the elements of A, which are 1 2 3. Now as there is no repetition in case of sets, we don't repeat the elements in the set, so we will write only 1 2, which will appear outside 1 2. Now as we have written 1 2 3, we are left with 4 5 in the universal set, because all these sets are contained inside the universal set. 4 and 5 are left, so we will write 4 and 5 here. Okay, now the question here asks us about A union B. The first thing, before I go into the operations, I want to tell you that the diagram will now remain the same in each of these, whether the question is different, but the diagram will remain the same. So that means if you have identified in the beginning that this is the diagram I'm gonna draw, that means it will go on for every operation. In this case, I have 3 1 2 4 5. Let's copy it everywhere. 3 1 2 and 4 5. 3 1 2 and 4 5, and 3 1 2 and 4 5. Okay, now let's come to the operation. In the first case, it is A union B. Now in A union B, we basically write all the elements together, that is, we combine the elements of the two sets. So I will write it as C 1 2 3 and 3. So that means this combinedly will give me 1 2 and 3. Now look at the answer. The answer is 1 2 3. Now where in the diagram does this 1 2 3 appear? It appears in both the sets 1 2 and 3. So I am gonna shade it like this. I will only shade these two circles, not the outside area, because the elements in the answer is 1 2 3. Coming to A intersection B. Now A intersection B means the common element in A and B. Now by common, what you mean? By common, you mean the element that is repeating in both. Like in this case, we have 3 and 3. 3 and 3 is same. That means the answer for A intersection B is 3, right? So which area will be shaded? The B part, because this is the intersection which is common. As you can see, B is contained in A, so B will be shaded, right? Okay, now moving to the A complement. A complement is also shown in this way, A to the power C. This also means A complement. Now what does A complement means? A complement means you have to delete the element of A from U, that is U minus A. Okay, so when we eliminate the elements of A from U, see 1 2 3, that means we need to cancel this 1 2 3, or we have to remove these 1 2 3, because this is the common element appearing both, and we have to remove A from U. So the answer will be 4 5. 4 and 5. Now as you can see in the answer, 4 5 is the outside area, which is U. So you will shade this U part like this. Yes. Okay. Moving to B complement. Now A is A complement meant U minus A. B complement will mean U minus B. That is, you have to subtract the element of B from U. Now in this case it's only 3. That means 1, 2, 4, 5 will be the answer. 1, 2, 4, 5, right? Now that means you have to shade everything apart from 3. So 1, 2, 4, 5 appears here. So let's shade the outer area. In the set A. We don't have to shade the set B. So that's how you do it. Okay, now moving to A minus B. What does this mean? A minus B, only two sets are involved, A and B. Now you have to subtract the element of B from A. In B we have 3, we have to eliminate this. So that means we will get 1 and 2. So that will be 1 and 2. And 1 and 2 appear here. So that means we have this. This will be the answer. And this will be shaded, right? Okay, now as we are done with the first case, which was of subset, let's move to the case 2 and look at the two sets A and B. A is 1, 3, 5 and B is 2, 4. I can see, and you can also see, that there are no common elements between these, or no elements in these two sets are the same. That means this case is the disjoint set. Okay, so let's again first write the elements of A, B and U, and then move on to solving the operations. In A, write the elements of A, which is 1, 3, 5. 1, 3, 5. Okay, in B you have 2 and 4. 2 and 4. Now all the elements are covered, 1, 2, 3, 4 and 5. So you don't need to write anything in U. Now let's find A union B, which again is the combination of A elements of A and B, which is 1, 2, 3, 4 and 5. So 1, 2, 3, 4, 5 appear in these two circles. So we are gonna shade these two circles, right? Because this is our answer. Now moving to A intersection B, and these, let's first write the elements of all these. 1, 3, 5, 2, 4. As I said in the beginning, all the diagrams will be the same for the operations if you have identified it in the very first place. 1, 3, 5, 2, 4. 1, 3, 5, 2, 4. 1, 3, 5, 2 and 4. Okay, now A intersection B means the common elements in A and B. As we know, this is the disjoint set, so of course there will be no common, so this is null set, and we have to show that no any element is in the answer, so we don't need to shade anything. We will leave it the same because there is no any common element. Now moving to A complement. A complement means U minus A. Now if we subtract the element of A from U, 1, 3, 5, 1, 3, 5, we get 2 and 4. So this will be 2 and 4. 2 and 4 is this part, so that means I will shade this. Okay. Now coming to B complement. B complement means U minus B, and let's eliminate the elements of B from U. 2 and 4 will be eliminated and we will be left with 1, 3 and 5. So it will be 1, 3 and 5. That means this part will be shaded. Okay, now coming to A minus B, again we have to subtract B from A. So there is no such element of B which is present in A, so the same element, so the same set will be in the answer, which is A, because we have to subtract B from A, right? There is no any element which can be subtracted from A because no any of the element is the same, so A will be the answer. That is 1, 3 and 5. Now look at the diagram and see 1, 3, 5 appears here, so we will shade this. Okay, now this part is done. Let's move to the third case, which is the overlapping case. As we can see in the sets A and B, 2 is the same, 2 is here and 2 is also here, but 3 is not the same, and in this case a is not here, in this case 3 is not here. So that means only a single element is same, or maybe more than that can be same, but not all are the same. So this case is overlapping. First, let's write the elements in the Venn diagram. In this case we have 2 as common, so this is the common area where we write all the common elements. So I will write 2 here. As I have written 2, we are left with 1 in set A, so I will write 1 here. Now in case of B we are left with 3, so I will write 3 here. Now we have written 1, 2, 3 and we are left with 4 and 5, so I will write 4 and 5 outside. And again the same diagram is when you have identified it in the first place, it will appear everywhere. So I will write it the same: 2, 1, 3, 4 and 5, 1, 2, 3, 4 and 5, 1, 2, 3, 4 and 5, 1, 2, 3, 4 and 5. Now let's move to the operations. A union B. A union B is again the combination of A and B, so 1, 2, 3. Now let's see, 1, 2, 3 appears here, so this means this part will be shaded. Wherever the answer is, we shade that part. Okay, like this. And then let's move to A intersection B. In case of A intersection B, we write the common element. In this case we have 2, so let's write 2 and shade only the part which is in the answer, that is 2. Now in case of A complement U minus A, that is we have to eliminate the elements of A from U. If we eliminate 1, 2, we are left with 3, 4, 5. So it will be 3, 4, 5. Now let's shade it. 3, 4 and 5 appear here, so that means the outside area is shaded. And then this part of B is also shaded because 3 appears here. And this is the remaining part which will not be shaded. Now let's move to B complement, which means U minus B. In this case we have to eliminate the elements of B from U. We have 2, 3 in B, so when 2, 3 is removed we get 1, 4, 5. 1, 4, 5. So that means this one will be shaded, right? And this 4, 5 outside will be shaded. Yes. Okay, now the last case where we have A minus B, that is we have to remove elements of B from set A. Elements of B present in A is only 2, that means 2 will be removed and we will be left with 1. So that means this 1 is the answer in this case, and 1 appears here, so this part only will be shaded. So it's that super easy. If you once find out what the relationship is, you can easily color and you can easily shade the diagrams, and you can easily make the diagram before you shade the diagram. So that's how you do it. I hope you like the video, and wherever you have any confusion or any question, you can ask in the comment box. Thank you, and please do subscribe to my channel.